Hello students, welcome. Previously, lesson 5 from 4 topic 6, we were dealing with the second part of alkanoic acids, where we have done the physical and the chemical properties of alkanoic acids and the uses of alkanoic acids. So today, lesson 6, we want to proceed to the third part of the topic, that is detergents. So in this lesson, we are going to see the two types of detergents, and specifically we'll be talking about the soapy detergents, which is also known as soap. Number 2, we are going to see the laboratory preparation of soapy detergents. Then number 3, we are going to do the mode of action of soapy detergent in cleaning. Kindly stay with us until the end of the video. So we're saying detergents are substances which improve the cleaning properties of water, because we are told water alone cannot remove dirt from a cloth. So detergents are used to improve the cleaning properties of water. So next we are saying there are two types of detergents. The first one is called soapy detergent, which is also known as soap. Then the other one is known as soapless detergents, which is also known as detergents. So we are going to start with the first type of detergent, that is soapy detergents. So we're saying soapy detergents are referred to as soaps. They are prepared from either fats or oils. So next we are saying soap is a sodium or potassium salt with a general formula of CnH2n plus 1 COONa or CnH2n plus 1 COOK. So therefore what we can say is that soap is a sodium or potassium salt of long chain alkanoic acids, also called fatty acids. So next we are saying fats and oils are esters. Then next we are saying fats naturally occur in animals, while oils occur in both plants and animals. So next we are saying fats are saturated organic compounds, while oils are unsaturated organic compounds. So to differentiate between fats and oils, we are saying first of all we are supposed to add a few drops of acidified potassium manganate 7 solutions. So we're saying in oil, bubble acidified potassium manganate 7 solutions will be decolorized. That means, remember, oil is unsaturated organic compound. So it's supposed to decolorize acidified potassium manganate 7. While in fats, we are told the acidified potassium manganate 7 solutions will not decolorize. That means it will remain bubble, because fats are saturated organic compounds. Next, we are seeing soaps are formed when fatty acids react with the sodium hydroxide or potassium hydroxide. For example, we are told when octadecanoic acid, also known as stearic acid, reacts with sodium hydroxide, we are told sodium octadecanoate and also water are formed. So the sodium octadecanoate is our soap or the soapy detergent. So the question for that reaction will be, this is what we are going to have: octadecanoic acid or stearic acid reacting with sodium hydroxide solution, giving us the sodium octadecanoate, which is the soap, or which is the soapy detergent and also water. Next, let's proceed to the laboratory preparation of soap detergents or soap. So we're saying 5 cm cube of vegetable oil is mixed with 20 cm cube of 4 molar sodium hydroxide in an evaporating dish, and we're saying we heat the mixture on a water bath for 20 minutes. Stir continuously while adding a small amount of distilled water. Next, we're saying add 3 spatula fulls of sodium chloride, stir the mixture and allow it to cool. Next, what we are supposed to do is we filter the mixture and wash the residue, that's the soap or the soapy detergent, with the cooled distilled water and dry it. So we're saying next bonds to note or notes. Number 1, we're saying solid sodium chloride is added. Remember we said add 3 spatula full of sodium chloride. So the reason why we are adding solid sodium chloride is that to reduce the solubility of soap in glycerol, or we can say in order to precipitate the soap. So we are saying this separates soap from other products formed in a process called salting out. So salting out is the process of precipitating the soap or reducing the solubility of the soap in glycerol. Next, we are saying the soap obtained is rinsed in distilled water. Remember here we said filter the mixture and wash the residue, that's the soap, with cooled distilled water. And the reason why we are rinsing in cooled distilled water is to remove impurities such as glycerol, sodium chloride, and the unused alkali solution. In our case, sodium hydroxide solution. So when we are preparing soap in the lab, the product formed during manufacture of soap is soap and glycerol. So that means glycerol is one of the impurities present in the soap. So the second is, remember, we said sodium chloride is added to the mixture so as precipitate the soap or to reduce the solubility of the soap in glycerol. So that means it is also another impurity present in the soap. Then next, the unused alkali solution. Remember, the sodium hydroxide was in 4 molar, so it was in a high concentration. So that means some of it will remain or will be unused. So next we are saying saponification is a process whereby soap is manufactured by hydrolyzing a fatty acid or vegetable oil with the alkali, that's sodium hydroxide. And we are saying in the hydrolysis of a fatty acids, sodium hydroxide neutralizes the acid to form the sodium salt of the acid. For example, so here what we are going to have is the fatty acid reacting with 3 moles of sodium hydroxide solution, which is our alkali, and what we are going to get is sodium octadecanoate, which is the soap, but as glycerol. And glycerol is also known as propan 1,2,3-triol. So sodium octadecanoate is also known as sodium stearate, because remember, sodium octadecanoate is formed by the reaction between stearic acid and also sodium hydroxide. So next we are saying during manufacture of soap, there are some additives that are added to improve its quality. That's number 1, addition of coloring agents. Number 2, addition of builders, e.g. tetraoxophosphates and also dyes. Number 3, addition of antiseptic. So next we are going to go and see the mode of action of soap in cleaning. So we're saying the cleaning effect of soap is brought about by the ion, that is RCOO minus, in other words the alkanoate ion, which consists of 2 parts. So we are saying they are a head comprising of the negatively charged carboxyl group written the COO minus, and a long tail comprising of the hydrocarbon chain. So next we are saying the head is polar or hydrophilic. Hydrophilic means water loving, while the tail is non-polar or hydrophobic. That means water heating. So here in part A and part B, we are having the anion side of the soap, where we are going to have the tail and also the head. In our case here, we are dealing with the condensed structural formula. So this is the tail, which we have said it is the non-polar side, or we said it is the hydrophobic or the water heating part, and this other side, the COO, is our head, where we have said it is the polar part. Therefore, that means it's also called hydrophilic or water-loving. So in part B, we're having just, it is a skeleton formula. This one was condensed structural formula, and here it is just, we have written the hydrocarbon in skeleton formula. So this is the nonpolar tail. So this part here will be the polar head. And remember, the polar head comprises of COO minus. So we're saying the cleaning action is affected in the following two ways. Number one, we're saying the polar head interacts with water molecules, lowering the surface tension of water, hence enabling close contact between water and the object being cleaned. So number two, we are saying the nonpolar tails of soap are attracted to the grease or oil particles, which are also nonpolar, just like the nonpolar tail. We are saying this loosens the attraction of the grease on the surface being cleaned. As the surface is scrubbed or agitated, we are saying the grease particles come out and break into many tiny particles. Each of these particles gets surrounded by the nonpolar tails of the soap molecules whose heads are oriented to the water. And we're saying the resulting structures are called miscellaneous and remain suspended in water. So next we are saying they cannot coalesce. That means they cannot come together because they repel each other due to the similarly charged polar heads, and we are saying they are subsequently removed with the washed water. So that means during rinsing they are removed from the cloth or from the garment. So we're using these two diagrams to explain what we have discussed here in number 2. So the first part here, part A, is where the nonpolar tail of the soap is attracted to the grease or the oil particles, which were nonpolar when we're dealing with this. So here we're having grease droplet with soap molecules on its surface. So next in this part B, it is where the surface is scratched. It's when the surface is scratched or agitated and the grease particles came out and break into many tiny particles. This is a particle, and this is a particle, this is a particle. And we're saying each of these particles gets surrounded by the nonpolar tail. So that is the nonpolar tail of the soap. So here we're saying thin grease particles enclosed by soap molecules, and that's what we were saying, miscellaneous. And remember we said these miscellaneous are suspended or are removed during rinsing, or they are suspended in wash water. Learners, that's the end of our class today. Thank you for watching.